Hi, this is Zachary Toranzo, and I will be covering the topic of line squares. Line squares are designed used to control experiments and lessen variation. In statistics, line squares is used to study multiple factors at once to control variations in two directions, rows and columns. Use of this is to reduce randomness in experience and control two or more variables, where the factors will be n times n, as shown here. The first one being a 3 by 3, second being 4 by 4, and fifth one being 5 by 5. Where in the experiment it will receive the treatment once. To follow the common principle of line square designs that are translated into the popular game of Sudoku, that treatments, or in Sudoku's terms, numbers, only appear once per column and row as seen with these varying simple examples. The first being the game Sudoku, with the 9 3 by 3 line squares where the same rules apply. The second being a simple line square example in visual terms of color where no color repeats itself in the specific column or row. And the final example being an advanced version of the Latin square design called the Greco-Latin square, where the factors in question are greater than 2. The example of buses, drivers, and days trying to determine fuel usage, where each treatment is with a new blocking factor of a driver denoted by Greek letters, where days is 1, 2, 3, and 4 as columns, and buses 1, 2, 3, and 4 as rows, and A through D being a different type of fuel treatment, and alpha, beta, y, and gamma, or the bus drivers being the different factor. The ANOVA degrees of freedom, in statistical terms, line squares are involved with degrees of freedom and are done by the n number of rows, columns, and treatments, and n minus 1, and the rest of the ANOVA analysis as follows. And the treatment effects and means are orthogonal to the rest, the rows and column effects. And with this, the computation is quite simple. And my engineer example, which is related to civil engineering and being a structures example rather than the commonly used agriculture example as my field of desire. We have four materials where material 1 and 2 are the same but varying thickness, as in just regular wood with different thicknesses. And the same will be applied with materials 3 and 4 being a different material like compact wood or compressed with different thicknesses, and with the different treatments being applied are denoted by A through D as varying levels of force to determine which material will be best to use. And this is the citations.